Good day, grade 12 learners. Welcome to today technical science lesson. My name is Thabang Mongatani. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Grade 12, today we'll be doing the revision of all the work that we have done from January until now in paper 1, but only in paper 1. If you have any question, remember our WhatsApp line is 060-667-5044. The WhatsApp line for any question, that WhatsApp your question to this number 060-667-5044. And our technical team is ready for your question. As you know, we start each and every lesson on the structure of paper 1. Paper 1 it has three content, which is mechanics, electricity and magnetism, sound, wave, and light. The marks of each are as follows. Mechanics is 93 marks, electricity and magnetism is 33 marks, wave, sound, and light is 24 marks, which weighs, mechanics weighs 62% of the whole paper, and electricity and magnetism weighs 22%, and wave, sound, and light weighs 16%. Total marks is 150, and then duration time that you need to complete the paper with is 3 hours. And our test in our exam, both prelim and final exam, you will find that 55% of the paper is level 1 and level 2 questions. Those are easier questions. We know that that means that it gives you are able to pass the test. And then 45% of the paper is level 3 and level 4. There we have many level 3 questions because of what? Lots of calculations in level 3. Okay. Allocation of marks in paper 1, it continues. The paper is separated into section A and section B. Section A, which is multiple choice questions, you have 10 multiple choice questions, which each multiple choice is 2 marks. That means if you have a 10 of multiple choice question, that means you will have what? 20 marks. And in section B is what we call structured or long question. That's where we find stating the laws, definitions, calculation, explanation. Yes, they are in section B. And that section B is out of 130 marks. And the total paper, as we said, is 150 marks, and time is 3 hours. And for the topics that we have already covered in term 1 and in term 2, they take plus minus 93 marks. That means our revision today will be doing revision of plus minus 93 marks. That it will require you to listen and participate in today's lesson, because you can't manage to lose these marks. 93 is too much. And our flow chart will talk about namely what we did in first term and second term. We did mechanics, which is what? We started with Newton's laws, we went to momentum, and we went to work, energy, and power. Then lastly, we did elasticity, Please correct that. It is supposed to be elasticity there. Supposed to be elasticity, viscosity, and hydraulics. Let's start with Newton's laws. Newton's laws, we have 3 Newton's laws that we need to know, which is Newton's first law, Newton's second law, and Newton's third law. And all these laws, they are very, very important. They are very, very important. Under Newton's first law, you must know the following also: mass and a weight. And you must be able to do what? To distinguish between mass and weight. We know there is a misconception when it coming to this mass and weight. Some people will say, I've lost weight, only to find that we're doing what? We are not losing weight, but we are losing what? Mass. And another thing that you need to bear and take, that is very, very important in first law and Newton's first law, is inertia. And then when you go to Newton's second law, we're looking at what? Acceleration, friction, kinetic friction, and static friction, free body diagram, and free force diagram. Then we go to Newton's third law. Under Newton's third law, we want to know about the interaction, because there is what? They say object A exert a force on object B exert the same force on object A. We want to know that interaction of forces between the objects. Momentum. Under momentum, we'll be looking at what? Newton's second law in terms of momentum. We'll be looking at impulse, change in momentum, conservation of momentum, isolated system, elastic and inelastic collisions. Then under work, energy, and power, we're looking at what? Work. We start with work, and then work, we want to know when is work done and when is work not done. And then we need to look at the relationship between the force and the displacement. And then we're looking at also the joules, which is the SI unit for work. Under energy, we look at what? Conservation of mechanical energy, kinetic energy, and potential energy. And then under power, we go to power. Power will be looking at what? Which is the SI unit for power, and kilowatt. Kilowatt, we know that kilo is what? 1,000 watts. 1,000 watts. And then we're looking at what? Horsepower and power and velocity. The formula where you need to calculate power, where you're looking at what? The force and the velocity. And then we go to elasticity, viscosity, and hydraulics. We start with elasticity. Under elasticity, we'll be looking at what? Deforming forces, restoring force, perfect elastic body, perfect plastic body, elastic limit, stress, strain, and lastly, we'll be looking at Hooke's law. Then we go to viscosity. Under viscosity, we'll be looking at the effect of temperature on viscosity. We're looking at if you increase the temperature of the fluid, will increase or decrease the viscosity of that fluid. And we're looking at what? Motor oil viscosity grades. Remember the 30W50, 35W40, those are the grades that we're talking about. And then we go to hydraulics. It's supposed to be hydraulics. Hydraulics. Under hydraulics, it's supposed to be hydraulics. And then under hydraulics, we'll be looking at what? At thrust, pressure, Pascal, atmosphere, bar, and torr. All these, they are what? They are SI unit for, they are units for our for pressure. Yes. And then we're looking at what? Fluid pressure, Pascal law, and hydraulics lift. Okay, grade 12s, I will always remind you on how definitions works. We say to you, when you write a test or exam, prelim exam or final exam, the following, bear in mind the following when it comes to definitions. We say the following definitions are very important. They must be mediated and be known by heart. That means you can't say because you are writing tomorrow, then you start studying the definitions. You must study them way in advance so that you go through them again and again and again so that you know them. Because once you make a mistake in a definition, you lose the whole 2 marks. There's no way that we're going to give you 1 mark because you forgot a certain aspect in that definition. No, we'll give you 0. That is why we're saying bullet number 2, it says, always follow the definition from exam guideline, not from the textbook. If you don't have an exam guideline at this time, grade 12s, please nicely go to your teacher, ask your teacher to make copies of exam guideline, and then you paste it in your book so that you don't lose it. All the definitions are awarded 2 marks if the definition is correct. When you write correct definition, we give you 2 full marks. If the definition is not correct, 0 mark will be awarded. If you give the wrong definition, that means you will not gonna get any mark. You will do what? You will forfeit that 2 marks for the definition. And remember, grade 12, how many definitions do we have in an exam? There are so many. You can get plus minus 30 marks from the definitions, either from multiple choice or from the giving or from giving the stating the law or giving the definition. Okay, and then we say if some part of the definition is correct and some part is incorrect, 0 marks will be awarded. We're not going to say because one part is correct and the other part is incorrect, then we give you 1 mark. No, when we come into definitions and laws, is 2 marks or nothing, is 2 or nothing. All the laws stated correctly will be awarded 2 marks also. Irrespective how long is the law or how short is the law, we give you 2 marks for each and every law that you state correctly. If the law is stated incorrectly, 0 mark will be awarded. Yes, like as we did with definition, if the law is not correct, then we don't get any mark. Then we continue. If part of the law is stated incorrectly and the other part of the law is stated correctly, 0 mark will be awarded. Yes, we don't give you a separate marks. Even you can see, even when we mark, the ticks are next to each other to show that we're giving two or nothing. Questions on laws and definition can be or will be asked in question 1 of the question paper in the multiple choice question. You will find laws and definitions in question 1 as part of what? Multiple choice questions. It's either you'll be asked to state the law, you are given the name of the law or the name of the definition, and you are asked to define or to state the law. Or we give you the whole laws and then we ask you to name that law. Or we give you the definition and we ask you to do what? To give us the name of the definition. Are we together? Like for example, if we say we can say to you, what is the product of mass and velocity? Then you need to give us the name of that definition, which is what? Momentum. Okay, grade 12. And then we say also, most of the long or structured question normally start with the definition or starting with the law. That will be question 2 to question 10. Are we together? That means before we start with a question, we'll ask you, define momentum, define work, or state Newton's second law, those kind of things. That will be 2.1. It will be define or state Newton's second law or define acceleration. Okay, we're gonna start with Newton's laws and then we start with the formulas. My question is, are you familiar with these questions that we see here on our screen? Do you know these formulas? Have you ever used them before? Have you ever chose the correct formula from the formula sheet? If your answer to all these questions is no, then you need to go back, or I know that some of you don't have the formula sheet. Please again, nicely ask your teacher to print for you the formula sheet, and you also paste it in your book so that you don't lose it. And then in that way, you'll be able to use it every day when you practice or when you're doing the classwork and the homeworks, or when you practice for the test or the exam. It will just be next to you. And it is very, very important that every time when you touch technical science books, you go first on information sheet to see if you are doing Newton's laws. You look at these formulas that you see in front of the screen and make sure that you know what is meant by each and every letter. You must know what is meant by each and every letter. For example, we know that this is a net force, and this is mass, and this is acceleration. And then this is the formula that we use for Newton's second law. Those are things that you need to know. Like for instance, this one also is what the P here is not for power, but is for momentum. M is mass, and then V is what? Velocity of the object. And then we go here, we found that we have what? Fs is what? Frictional, is a static frictional force. And then mu s is what? It's a constant. It's a constant of the surface. The how rough is the surface. Is for static friction constant, static friction constant, and the N there is what? Is the normal force. The N is the normal force. And then when we go here, we found what? The we found the kinetic frictional force. The K there, it means is kinetic, and the S here, it means what? Static. And then we have the mu K here, which is the constant of the constant between the surfaces. And then we have what? The normal force. It's a what? Constant of what? Of friction. Okay. Then we use this when we're dealing with what? When we're dealing with impulse. This formula, we use it when we're dealing with impulse. And then we can take the same formula and then change it so that we can use it in what? Newton's second law in terms of momentum. Like when you have F net multiplied by change in time is equals to change in P, then you can do what? Divide both sides by change in time. Then change in time will cancel each other. Then you're left with what? F net is equals to change in P over change in T. Then this formula here we said is the Newton's second law in terms of momentum. Are we together? And for the impulse, you can't do impulse without what? Change in momentum. You need to be able to calculate the change in momentum, where you have what? Initial final momentum minus initial momentum. Are we together, grade 12? Yes. And then this is our gravitational force, or this is our gravitational force. Fg is a gravitational force, and then the M is for mass, and G is what? A gravitational acceleration. Gravitational acceleration. And if you have any question, grade 12s, remember the number is 060-667-5044. Okay, let's continue. We're coming to the Newton's laws definitions. In Newton's law definitions, we're saying we start with Newton's law. State Newton's first law. We say Newton's first law is stated that an object continues in a state of rest or uniform or moving with constant velocity unless it's acted upon by a net force. If you don't want to say net force, you can say what? Resultant force. If you don't want to say the net force, you can say what? Resultant force. And if you don't want to say uniform, you can say what? Constant. Uniform and constant, they is one and the same thing. You can say Newton's first law states that an object continues in the state of rest or moving with constant velocity unless is acted upon by a net force. Are we together, grade 12? Yes. And then we continue. This is one of the laws that you must know. Are we together? And how do we represent this mathematically? We say F net is equals to 0. I know you're asking yourself why F net is equals to 0. Because we know normally that F net is equals to MA. Yes, grade 12 is equals to 0 because if the object is at rest, what will be the acceleration? The acceleration will be 0. Or if an object is moving at what? Constant velocity, what will be the acceleration? The acceleration will be 0. That is why we have what? F net is equals to 0 in Newton's first law. And then we look at mass. What is mass? Mass is a measure of the inertia of the body. We're saying from exam guideline, if you go to exam guideline, you'll see the definition of mass as what? The measure of the inertia of a body. And then we go to where? Weight. Let's look at weight. Weight is the gravitational force the Earth exerts on any object on or near the surface of the Earth. Weight is what is the force that pulls all the objects that are near or that are on Earth towards the center of the Earth. And then we also say weight is perpendicular to the Earth surface, not the surface, but the Earth surface. That means when you stand wherever you are, you can be in South Africa or you can be in America. You're standing perpendicular to the Earth surface. That is how weight acts, perpendicular to the Earth surface. We know that Earth is round, but wherever you stand on Earth, you will be perpendicular to what? To the Earth surface. Okay, grade 12. This is what weight is all about. It's what gravitational force is, the force of gravity, is the force that the gravity exerts on an object. And that object must be near the Earth surface or on the Earth surface. Remember, when the object is out in space, that object is not gonna experience what? Weight. No. Are we together? Because of what? We don't out in space, we don't have what? The weight changes. Like the reason why weight changes is because of what? Is because of this G. This G is only 9.8 meters per second squared only on Earth. Or for the object that is falling towards the center of the Earth is 9.8, it's a constant. But if you move far or you go to another planet, G is not 9.8, G changes. But only around Earth and on Earth is what? Is 9.8 meters per second squared. Let's look at the unit. Unit says what? Meters per second squared. That shows that this is what? This is an acceleration. It's acceleration due to gravity or gravitational acceleration. Are we together, grade 12s? Yes. We're talking about this G that you see here, this small g. Are we together? Yes. Let's go to inertia. Inertia, we say, is the property of the body to resist any change in its state of motion or rest. Can we repeat that? Inertia is the property of the body to resist any change in state of motion or rest. Okay, grade 12. This is a scenario. You are in a car that is moving at 120 kilometers per hour. And the driver suddenly hit the brakes. And you are not wearing a seat belt. What will happen to you? You will fly throughout the windscreen. Why? Because as the car was moving at 120 kilometers per hour, your body is also moving at that speed. When the car suddenly stops, your body still moves at 120 kilometers per hour. That means you'll be moving through the windscreen at what speed? 120 kilometers per hour. That is what? That is inertia. It resists that your body should change the movement, because now the situation says we are stopping, but your body still do what? Still moving. That is what inertia does. Like another example is, it is very, very difficult to stop a heavy vehicle than a small car. When you are driving a bus, to stop a bus, you can't just stop here. Why? Because the speed that the bus will be moving at, the bus, because of it has big mass, that means it will continue moving in that. As much as you can apply the brakes, the bus is not going to stop here where you apply the brakes. It will do what? It will continue moving for a distance before it can stop. That is what? That is inertia, because it does what? It resists the change. Now the change of movement, it says we are stopping, we are no longer moving, we are stopping, but the object still continues to move. Are we together? The same thing when you're in a car, the change, it says the car stopped, but your body doesn't change. It's still moving at the same speed. That is why it's so important, grade 12, to put on your seat belt so that to minimize the injuries. Because if you didn't put the seat belt on, that means the seat belt it can stop you from moving. But if you're not putting on the seat belt, then you are free to move at the speed of the car. Okay, grade 12. Let's continue. Acceleration. Acceleration, we said, is what? Is rate of change in velocity. What does it come to your mind when you see this word, rate? To me, when I see a rate in technical science, I know that I must divide by time. There must be time there. Are we together? Then that's why we say acceleration is what? Changing velocity over changing what? Time. This is what? The rate. The word rate, it comes from here. Are we together, grade 12? Yes. We say acceleration is what? The rate of change in velocity. And this triangle that you see here, it stands for what? Change. This triangle is what? It stands for change. And then what is change? Change, we normally say final minus initial. And because we're dealing with velocity, it's going to be what? Final velocity minus initial velocity. Are we together, grade 12? If you have any question, don't hesitate. Please, 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 WhatsApp us your question. We will help you to resolve the question that you are having. We continue with Newton's laws. We're coming to Newton's second law. It says that Newton's second law states that when a net force is applied on an object of mass m, it accelerates the object in the direction of what? Of the net force. And then we say the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. The reason why I wrote this formula here, I want you to see that there is a link, there is a connection with Newton stating Newton's second law in weight and this formula here. This formula, we use it for Newton's second law. It says, it states that when what? A net force is applied on what? On an object of mass m. This is mass m. And then it makes the object to do what? To accelerate. To accelerate in which direction? In the direction of the net force. Can you see? The net force is applied on the object of mass m, and that object will do what? will accelerate in which direction? In the direction of the net force. And we continue by saying acceleration is directly proportional to what? To the net force. And it is inversely, acceleration is inversely proportional to the mass of the object. This is what we're talking about. If they ask you, they do ask you that state Newton's second law using mathematical equations. This is how you need to write it. But in most cases, we do what? We can only ask you to do what? To state Newton's second law in words. Then when you state Newton's second law in words, this is how you state it. You say what? Newton's second law states that the net force is applied to, when the net force is applied to an object of mass m, the object will do what? The object will accelerate in the direction of the net force. And we say acceleration is what? Directly proportional to the net force, and acceleration is inversely proportional to what? To the mass of the object. Okay, then let's continue with our definitions. Remember, grade 12, you need to meditate on these definitions and these laws. Friction force. We use this symbol for friction force. We say L is the force parallel to the surface that opposes the motion of the object. It does what? Opposes the motion of an object, and it's acting what? It's act in the direction opposite the motion of the object. What does that mean? I have this. Let me use this. I have this object here. And then this object is moving to the right. That means between this object and the surface here, there is what? A friction force. And then if this object is moving to the right, that means friction force will move to the left. That's how we explain friction force. And the surface must be rough. If we're dealing with a smooth surface, that means our friction, we say we're dealing with what? A frictionless surface. But if we're dealing with a rough surface, normally when we bring the question that has to do with friction force, we'll state that a car is moving on a rough horizontal surface. You hear? When you see the word rough, you already know that there is a friction there. And then even if you have to draw what? The free body diagram or the force diagram, then you already know that because there is a rough there, it means that there is a friction force. I need to add it on my free body diagram. Are we together? Yes. We're saying the frictional force is parallel to the surface. You see, if this table is the surface, that means it must be parallel. It can be perpendicular or at an angle. No, it must be parallel. And if the surface is diagonal like this, also it must be if the object is moving upwards, that means the frictional force will be moving downwards, down the slope. If the object is moving up the slope, the frictional force will be moving down the slope. Or if the object is moving down the slope, the frictional force will be going where? Up the slope. Are we together, grade 12? Yes. Then we have two types of friction force. We have a static and we have kinetic. Static. Let's start with static. We said is static limiting frictional force. Is the force that acts between the two surfaces when the object is stationary. Okay, what do you mean? Because there is a force and the object is stationary. You apply a force and the object is stationary. Sometimes when you push a table, you find that you push something, né? And then with a little amount of force, you'll find that that object is not moving. The reason why it's not moving is because of what? The frictional force is acting against your applied force. And maybe it's equals or more than your applied force. If I'm pushing this desk to the front and then not with enough force, then the frictional force is there at the bottom of the table next to the just parallel there, the surface, then is acting backwards while I'm pushing the table to the front. And then because I'm not pushing with enough force, then the table will not move. That is where we're saying the frictional force that is acting there, it is what? It is a static frictional force. Because static, it means what? Stationary. Are we together? Then we come to the kinetic or dynamic frictional force. In order for kinetic frictional force to be there, we must overcome the static friction. I'll start pushing the table with a certain force, and then in order, then the static frictional force will be there. And then when I apply more force, then you'll find that now I'm overcoming the static friction because the force that I'm applying is more than the static frictional force. Then the table will be able to move. And even when you're pushing a car, when you push, you find that one person can't push a car. But when you are 2 or 3, you are able to push a car because of what? You overcome to what? A static friction, and then now you are applying what? Then now a kinetic friction is the one that will be taking place because the object now will be moving. The object is moving, but there's still what? A friction force. That kind of friction force is what? Kinetic friction force. That is why we say kinetic frictional force acts between two surfaces when the object is moving. It doesn't mean when the car is moving, we don't have a friction force. There is a friction force. The friction force is what? It's static. Are we together? Have you ever pushed a car where the handbrake is up? When you push a car and the handbrake is up, will the car move? No. Why? Because of what? It apply what? Static frictional force. The car will do what? Apply a static frictional force against your applied force. Are we together? But once you lower the handbrake, then you are able to do what? To change static frictional force into kinetic frictional force. The friction force will be there, but the object will be moving. Okay, let's go to Newton's third law. Newton's third law, it states that when object A exerts a force on object B simultaneously exert an oppositely. Can you see what I'm highlighting? Simultaneously, oppositely directed force of equal magnitude on object A. That's why we write this. F Can you see? We're saying when object A does what? Exert a force on what? On object B. Can you see? When object A exert what? A force on object B, object, and then we say object B simultaneously. This is not action reaction. I don't slap you and you slap me after. No. Immediately when you push the wall pushes you at the same time, simultaneously. You don't push the wall and tomorrow the wall push you. No, 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 no. Simultaneously, the wall will push you. And then will simultaneously, oppositely. You see this negative sign here. It means that now the force that the wall is pushing me is in the opposite direction. I was pushing the wall in this direction, and now the wall is pushing me backward. Are we together? And then with what? Equal. If I'm pushing the wall with 50 newtons, that means the wall will push me back with what? 50 newtons. Are we together? Yes. Like for instance, I normally give this example that if you have a roller blades or a skateboard, just take them and stand next to the wall and then push the wall. You'll see immediately when you push the wall, you'll be moving backwards yourself. Why? Because simultaneously, immediately when you push the wall and then the wall pushes you back, that means there is what opposite direction that the wall is pushing you, and there is what simultaneously, because immediately when you touch the wall and push, then the wall will you'll start moving backwards. You will start moving backwards to show that the wall is pushing you at that moment. And then with the force that is equal to the force that you are pushing the wall with it. Are we together? If you are pushing the wall with the force of 100 Newton, that means the wall will push you with the force of what? Of 100 Newton, but simultaneously and backwards. Are we together, grade 12? Yes. If you have any question, please don't hesitate. WhatsApp us. And then we say properties of action, reaction, force, pair. We talk about what? Equal magnitude of what? Of force. The force that we're pushing the object with is the same force that the object will push you back. And then the opposite direction. That is why this side, you don't have a negative sign, but this side, can you see? We write it like this. This side, we don't have a negative sign, but this side, we have what? Negative sign to show that this is opposite direction. And then there we say the object, the forces act on different object. I'm pushing the wall and the wall is pushing me. You see, there's two objects there. Is the wall and is me. With our forces, we push each other, and that's why we say different objects. Okay, let's continue. When I go to most schools, the learners, they don't say free body diagram. They're using a certain term. Normally they say free Marx diagram, but I will want you to use free body diagram. Free body diagram is where most learners, they get their marks from, as long as they follow the tips. Are we together, grade 12s? Follow the tips that we are giving you. What is a free body or force diagram? We say free body or force diagram are diagrams that are used to represent the forces acting on an object. They are what? Diagrams that are used to represent the forces that are acting on an object. And then we use arrows to represent those forces. We use what? Arrows. Arrow. This is an arrow. It must have what? Magnitude and direction. Can you see? Where the arrow points is what? Is the direction of that force. Okay. Let's rush to tips. Tips, we're saying tips on drawing free body diagrams and force diagram. The first firstly we say draw a dot to represent the object. If that is this, we use it when you draw what? Free body diagram. When we draw free body diagram, we're gonna use what? A dot. And my advice to you, grade 12, is that when you draw a dot, make sure that you draw a bigger dot. Don't just draw a smaller dot. Are we together? Because if you draw a smaller dot like this, then the forces all the forces might not fit on that dot. Are we together? Draw a bigger dot like mine here. Ne? And then second bullet, it says determine the number of forces acting on an object. How will you determine the number of forces that you must draw? The marks allocated will give you direction. If the mark is 3 marks, that means you must draw how many forces? 3 forces. If the marks allocated is 4 marks, then that tells you that you must draw how many forces? 4 forces. And if you have a 5 marks, that means you must draw how many forces? 5 forces. That is why here the last bullet we say the mark allocated must match the number of forces to draw. The marks allocated must match the number of forces to draw. Are we together? Yes. Then the third bullet, it says use a ruler. Use what? A ruler, because a force must be a straight. It should not look like mine here. Can you see? It shows that I didn't use a ruler. You must draw neatly. You must draw, your forces must be, your free body diagram must be neat. Are we together? Must be neat. And to make it neat, use a pencil and use a ruler. Are we together, grade 12? Use a ruler to draw the arrow to represent the force that is acting on an object. Like you'll take a ruler, put it there, and then do what? You draw. And then at the end of the line, then you just put arrow to show what? To show the direction of the force, like as I did here. And they say, ensure that arrows must be in contact with the dot. Are we together? They must touch. When you use a ruler to draw, those are forces. Make sure that you start at the middle of the dot. That is why you need to draw a bigger dot. You start at the middle. When you start at the middle of the dot, you'll make sure that the force is in contact with the dot. And remember, the dot represent what? Represent the object. And then when we draw the force diagram, that means we're not going to use the dot, but we'll use what? The object itself. Like when they say a ball, that means you'll draw a line. We'll draw a circle like this. And if they say it's a box, you'll draw a box. Can you see? When you're drawing the force diagram. But when you're drawing the free body diagram, you draw what? A dot. But when you draw the force diagram, you draw the object as it is. Are we together? If it is a box, then you'll draw the forces from the box like this. Can you see, grade 12? Yes, that is how we draw the free body and the force diagram. And if the marks are 3, that means I'll have 3 forces. I'll have 3 forces. I didn't use a ruler, but when you draw grade 12, please make sure that you are using a ruler. Are we together, grade 12? Okay, we are done with Newton's laws. Now we go to momentum. Definitions for momentum. We say momentum is what? Product of an object's mass or its velocity. It's what? The product of an object's mass and its velocity. And then linear momentum is what? Is a vector quantity. Can you see? Linear momentum is what? It's a vector. Are we together? The same with forces. The forces are vectors. Why are we saying they are vectors? Because they have what? Magnitude and direction. They have what? They are vector quantity with the same direction as the velocity of the object. Okay. We're saying in linear momentum, a linear momentum is a vector quantity with the same direction as the velocity of the object. That means if we want to know what is the direction of the momentum, linear momentum, we'll say where is the direction of the velocity. That means the linear momentum takes the direction of what? Of the velocity. If the ball is moving to the right, that means momentum will be moving to the right. Are we together, grade 12? Yes. And then we go to Newton's second law in terms of momentum. Remember we said Newton's second law in terms of momentum is what? F net is equals to change in momentum over change in time. F net is equals to change in momentum over change in time. Are we together? That is Newton's second law in terms of momentum. While Newton's second law, it says F net is equals to ma. That is Newton's second law. Can you see the difference? Newton's second law in terms of momentum. They are different. They are different, but they are not different because you can, from here, you can get to here, and from here, you can also get to there. How so? Because we know that from here, we have what? Let me just... From here, we can say F net is equals to change in P over change in T, which is the same as M V final minus V initial divided by change in time. Change in time. What is this? This is a change in velocity again. And it tells you that it's a change in momentum. Then we say this V here, we can just write V M V over T. What is this? We said it's what? Acceleration. Then we have what? Equals to ma, because this is what? It's a acceleration. Remember when we're doing the definition for acceleration, we said the rate of what? Change in velocity, grade 12. That is where we move from here to here. Are we together? We move from this to this. Can you see? It's the same. It's the same. But we're just saying Newton's second law in terms of momentum. Here we're not using acceleration, but we're using what? Momentum. That is why we state it like this. We say Newton's second law of motion in terms of momentum state that the net force acting on an object is equals to the rate of change in momentum of an object in the direction of what? The net force. In which direction? The direction of the net force. Are we together? The net force is equals to the rate of change in momentum in the direction of the net force. Are we together? Yes. And the net force is equals to the rate of change in momentum. That is what I wrote here. F net is equals to change in P over change in T. As I said, when you see change in time, you know that is what is rate. Are we together? And then the impulse. How do you get the impulse? The impulse, we're saying the impulse is what? Is the same formula. F net is equals to, or F net multiplied by change in time is equals to change in P. Are we together? That means you can say impulse is equals to change in momentum or equals to F net multiplied by what? Change in time. Are we together? That is impulse. That is why we say impulse is the product of the net force acting on an object and the time the net force act on the object. Are we together? Is the net force acting on an object and what? The time is the product of the net force and the time. Are we together? That is how we define impulse. And we say impulse is equals to the change in momentum. That is why I wrote here. Can you see this? Impulse is equals to the change in momentum. Are we together? Impulse is equals to the net force multiplied by change in time, and impulse is equals to change in momentum. Can you see? Both they are equals to equals to the impulse. Okay, grade 12. Let's continue. Principle of conservation of linear momentum. It states that is the law. It states that the total linear momentum of an isolated system remains constant, or it is conserved in magnitude and direction. You can say this, the principles of conservation of linear momentum state that the linear momentum of an isolated system remains constant. Are we together? In magnitude and in direction. Can you see? Or you can say it states that the total linear momentum of an isolated system is conserved in magnitude and direction. Are we together? Is conserved or remain constant. Are we together? Is either we're going to say remain constant or is conserved. Are we together, grade 12? Yes. Okay. Now we continue. What is an isolated system? This isolated system here that is used in the principle. We say isolated system is the system on which the net external force act on the system is zero. That means we don't allow any external force. If everything, it happens in the container, everything that comes outside, we don't allow it inside. Are we together? Like, let's be realistic. In momentum, we talk about collisions. And we normally talk about a taxi and a car colliding with each other. And we know that after collision, the mass are not the same. Because after they collide, some parts will fall down. Are we together? That is why we're saying in an isolated system, We say, we take it, we say consider, we say ignore that the parts are falling down. There is a collision, then it does what? There is a collision, then the mass of the object before is equals to the mass of the object after collision. We don't count we don't take as if the parts will fall down. Are we together? That is where in an isolated system comes into play. But if from this principle we remove isolated system, that means will be what we're talking about is not going to be realistic in all the scenarios. Are we together, grade 12s? Yes. That is why we say in an isolated system, we don't include anything, any other factors that are coming outside. We don't take the net external forces. We say the net external forces is what? Is zero. We only taking into consideration what is taking place inside the system. Are we together, grade 12? Yes. Application of impulse in everyday life. How can impulse help us in everyday life? The reason why we have airbags in cars is because of what? The impulse. The reason why we have a seat belt in the car is because of what? Impulse. The reason why we have a arrestor bait on the road that helps you to stop. If you are coming, normally if you are coming to a T junction like this, you are coming this way and you didn't know that there is a T junction there, the road ends there, then you'll find that there is a arrestor bait on the road so that they help you to stop quick, especially for those big vehicles like truck and buses. They don't stop easily. Then they're able to go on the arrestor bed, and arrestor bed will increase the friction. Are we together? Arrestor bed will increase the friction and then will increase the frictional force, and then it helps the object to stop. Are we together? And crumple zone. Crumple zone is the front and the back part of the car. The reason why we have a long, long part in front of the car, like if you have a car like this, the reason why we have long here is because of what? During collision, whatever you collide with, in order to reach you here as a passenger, it must take time. Are we together? And even someone collide at the back, you have a collision from the back, then to reach you here, they must go through the cramp zone. This is the cramp zone that we're talking about. They must go through the cramp zone, and by the time that car reaches you, the car will be stopped, and then the injuries are limited. Just imagine if you are in a taxi and then in the front seat and there is a head-on collision. Because the taxi has a smaller cramp zone in the front, then that is why it is very, very difficult to get out of that accident alive. But because of this cramp zone, if the taxi has a bigger cramp zone, you can see now the new taxis, they are trying to increase the cramp zone, crumple zone, so that to limit what to reduce the injuries. Are we together? Yes. Let's go back. Oh. I went too far. Okay. Yes, I'm here. Thank you. I just want to go back one slide. Yes. Application of impulse in everyday life. We have 4 applications. The first one is airbag. Second one is seat belt. The third one is what? It's a arrestor bait. And the fourth one is what? Crumple zone. Are we together, grade 12? Yes. Let's start with airbags. When the airbag is inflated, let's say you are in an accident, you collide with another car, the airbag will be inflated and they will do what? They will stop you. Are we together? It prevents the passenger and the driver from moving forward during the impact. Remember when there is a head-on collision like this? If there is a head-on collision like this, because the car, as we're talking about in Asia, because this car was moving at 120, and then that means you as a passenger and the driver, you are moving at the same velocity. Okay, let's take a 30 minutes break. 30-second break, sorry. 30-second break, we'll come back. 30-second break, we'll come back. Okay, grade 12, we are back. We say airbag in a car. When the airbag is inflated, it prevents the passengers and the driver from moving forward during the impact. The collision time is increased, and the force is what? Is decreased. Why are we saying this? Remember, grade 12, we say impulse is equals to F net multiplied by what? Change in time. Are we together? That means when you increase the time of impact, then you are decreasing what? The force. Are we together? You can write it like this. You can say F net is equals to impulse over change in time. Are we together? Because when you divide both sides by change in time, are we together? Then you can see that when I increase the time, I'm decreasing the force, and also because I'm decreasing the force, that means I will be decreasing also the impulse. Are we together? The impact. Are we together? Because the force and the impulse, they are directly proportional to each other. That means when I increase the force, I'm increasing the impulse. When I decrease the force, I'm decreasing the impulse. That's what it means. It starts with what? The airbag will delay me to go and collide with the windscreen. And remember, if I collide with the windscreen, that's where the injuries will be more. If you're driving a car like mine that doesn't have a airbag, that means I'm risking. If it happened that I'm involved in an accident, I will be getting injured. That is how important is the airbags. Are we together? The same with seat belt. Seat belt, it protects you during collision because your body is still moving with the speed of the car. You must move. The body wants to move forward out of the windscreen. But because I have a seat belt on, then the seat belt will do what? Will stop me from moving front to the front. Are we together? The same with airbags. Airbags will be in front of me. Then instead of For me, instead of me to collide with the windscreen, I will be colliding with what? With the airbags. Are we together? And then by doing so, the airbags will delay my body to collide with what? With the windscreen. Then by delaying, it means what? It's taking time. It's taking longer time. The same with seat belt. It will delay my body to go and collide with the windscreen where the injuries are. And then because now my body is being delayed to collide with the windscreen, then the injuries are less because the force that I'm coming with to the windscreen will be now less. Are we together? Another example is those who play cricket. When you catch a cricket that comes, that has been thrown at a very, very high speed, you don't stop it like this. You stop it like what? Moving your hands backwards. Are we together? You are delaying the ball to hit you inside the hands, in your palms. Are we together? You are delaying, you put your hands like that, and then you move it backwards like this. And you are delaying it so that when it reaches your hands, then the force, the time has increased and the force has decreased. Then the ball is not gonna hit you. Are we together, grade 12? Yes. And then we continue to the arrestor bed. Arrestor bed, you'll see when you move, is either they put gravel road or sand, and sometimes on the tar road, you'll see that next to the stop sign, they do what? They put some, they build some smaller humps, the small humps that will help you to do what? To say when you move on them, to say grr, 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 to show that they help you to stop because they're increasing what? The frictional force on your wheels, on your tire, and then you are able to stop. And also, it doesn't only help you to stop, it only if like you're driving at night and you are sleeping, then it helps you to wake you up. Are we together? That is what arrestor beds does. It's either you'll find out that normally the truck, when they are about to stop, they'll move outside from out of the road, tar road, and move on a gravel path so that it can help them to stop, or the sand outside the tar road. Crumple zone, as we increase it, we say it does what? It delays the car that you are colliding with to reach you. Are we together? It delays the car to reach you. It increasing the time. Before the car reaches you, the car will already be stopped. Then the injuries will just be minor because of this crumple zone. But if the car didn't have a crumple zone, that means every time when you are involved in an accident, you will suffer the great injuries. Are we together, grade 12s? Yes. Work, energy, and power. These are the formulas. This formula is for work. It says force multiplied by what? Multiply by changing multiply by displacement at a certain angle. Are we together? And then this one, we use let's start with this. This is kinetic energy, where we have a mass and a velocity. The same here is either use capital letter K or EK. Are we together? And then we go to potential energy. This is potential in gravitational potential energy. This is a gravitational potential energy where you have mass, gravitational acceleration, and height. Why are we using that? Because we're dealing with the object that are moving a distance from Earth surface. Are we together? That is why we have G, the gravitational acceleration. Are we together? You can use capital letter U, or you can use what? EP for a potential gravitational energy. Are we together? And then when we take kinetic energy, we add it to potential energy, then it gives us what? Mechanical energy. You can see mechanical energy is equals to what? Kinetic energy plus potential energy. Are we together? And also, you can see here we have what? Change in kinetic energy. This is the formula to calculate the change in kinetic energy. Are we together? We said F is what? Final kinetic energy minus initial kinetic energy. We said the triangle, the smaller triangle that you see there, it stands for change. Ne? And then this one is power. Sometimes we use what? We say P is equals to E, which is energy, divided by time. Ne? Sometimes we use this. We say instead of work, we use what? Energy. Are we together? Then to calculate what? Power. Sometimes they're not going to give you work. They will give you what? Energy. Are we together, grade 12? Yes. And then this one here is the power also. We use what? Force and average velocity to calculate average power. Are we together, grade 12? Yes. This is force. This is average velocity. Ne? Sometimes they give you the force and the velocity and they ask you to calculate power. Then you'll be using this formula here. Are we together, grade 12? Then let's go to the definitions of work, energy, and power. Quick. We're saying work done. Work done is the product of the applied force on an object and the displacement in the direction of the force. Are we together? That means the force and the displacement must be in the same direction. Are we together? And then we say work is scalar. Why is scalar? When you multiply in two vectors, then you get what? You get a scalar. And then we say there is time where we have no work. No work is when the force and the displacement are perpendicular to each other. That means the angle between the force, let's say for instance, the force goes up and the displacement goes to the front. They're making what? They are perpendicular to each other. They form 90 degrees. And then we say the work there will be zero. Then we say we have no work. Negative work. Negative work is when we have what? We have the angle between the displacement and the force is 180 or greater than 90. Are we together? When we have a negative work is when the angle between the force and the displacement is 180 or greater than 90 degrees. And then we have a positive force, positive work, sorry. Positive work is when the force and the displacement are in the same direction or the angle between the displacement and the force is less than 90 degrees. Is 0 or 90 degrees is less than 90 degrees. Is 0 or is 0 degrees or less than 90 degrees. For negative, they are going in opposite direction. The force is going to the right, displacement is going to the left, then or the angle is what? 180 degrees or greater than 90 degrees. Then you'll get what? Negative work. Positive work, they are in force and displacement are in the same direction, or we have what? 0, angle of 0 degrees between the force and the displacement or less than 90 degrees. Then we'll have a positive work. Okay, energy. Energy is ability to do work. Are we together? That is what we mean. And then we say both work and energy are scalar. That means they have only magnitude, they don't have a direction. And The SI units, they're using the same SI unit, which is joules. Are we together? Yes. Work and energy, they are scalars and they use the same SI units, which is joules. And then the forms of energy, we have what? Kinetic energy, potential gravitational energy, and mechanical energy. Those are energies that we'll be dealing with. And then kinetic energy, we say, what is kinetic energy? Is the energy of an object due to its motion. If an object is moving at a certain velocity, then we can calculate kinetic energy of that object. Are we together? Is the energy of an object due to its motion. Ne? Then we continue. Gravitational potential energy of an object is the energy of the object because of its position from the surface of the earth. If the object is here and the earth is here, and this is 2 meters, the object is 2 meters above the earth, then we are able to calculate what? Potential gravitational energy of the object. But what if the object is on the surface of the earth? Then the potential gravitational energy will be 0 because the height will be 0. Are we together, grade 12? Yes. And then mechanical energy, we said, is the sum of what? Gravitational potential energy and kinetic energy. That means we're adding what? EP with EK. Are we together? We are adding EP and EK to get what? Mechanical energy. Then we have a principle of conservation of mechanical energy. It states that the total mechanical energy in an isolated system remains constant. Or you can say, it states that total mechanical energy or the sum of gravitational or kinetic energy. Are we together? Remember, mechanical energy is what? The sum of gravitational potential energy and chemical and kinetic energy. Are we together? Then you say principles of conservation of mechanical energy. It says what? It states that the total mechanical energy in an isolated system remains constant. In where? Isolated. Can you see isolated system comes again? You must know what is an isolated system. We don't allow any forces. In an isolated system, we don't allow any external forces to come in the system. That is where it says here also, when the net external force acting on a system is 0, that means any forces that is outside will be 0. Are we together, grade 12? Yes. We continue. The initial mechanical energy is equal to the final mechanical energy. Let's say now you are dealing with an object that is moving from here to here, or from here to here. That means we say the initial mechanical energy here is equal to mechanical energy here. We say this will be initial, this will be final. The mechanical energy is equal, the initial mechanical energy is equal to the final mechanical energy. Can you see grade 12? Yes. Because here we know that we have a height. But here, because the velocity is 0, because the object is not moving, that means we're only having what? Potential gravitational energy, while the kinetic energy is 0. And here, just because it reaches the ground, then we'll have what? Height is 0, but it's moving at a certain speed. It's moving at a certain velocity. That means the gravitational potential energy is 0, but we have what? Kinetic energy at the bottle. Are we together, grade 12? And we continue. Power. What is power? Power is the rate at which work is done. Can you see? At which work is done or energy is expended. Can you see? Work is done or energy is expended. That is why I said you can use this formula. P is equals to W over changing E, or P is equals to E over changing T. Can you see? This is for energy. Energy expanded is E, and then work done is W. Are we together, grade 12? Yes. And then practical units of power, we know them, is kilowatts. Ne? We write is kilowatts is equals to 1,000 watts. Are we together? Horsepower. Horsepower is what? Equals to 746 watts. That means this would help you to when you do the conversions. Are we together? They will ask you to convert horsepower into watts. Then you know that this is what you must use. And then we talk about the formula to calculate if they give you the force and the velocity. Then you are able to calculate what? Power by using F average is equals to force multiplied by what? A velocity average. Time is against me. We're coming to elasticity, viscosity, and hydraulics. This is the formulas that we've been dealing with them last week. Make sure that you know them. They're coming from your formula sheet. Then we're saying from there, you can see from there, this is what? Stress. This is the force. This is the area. This is the strain. This is the length where material has stretched. And this is the original length of the material. And then this is what? What do you call this? Modulus. Modulus we say is equals to the stress divided by what? The strain. And then this formula here, we use it when we're talking about what? Pascal lift. When we're lifting the hydraulic lift, the hydraulic lift. Now, where we have what? Force A with area A, that is exerted on area A, equals to force B, which is exerted on area B. How this? Like, you'll find that you have a pistol with smaller area and a pistol with bigger area. Normally, this area here will be A1 and this area here will be A2. Then here you apply a force here, and that force, it makes sure that the output force is bigger than the input force. That's when we're using this formula is for what? Hydraulic lift. Is the one that we use to lift the cars in the garage and many things that are heavy. Let's start with definitions. Definitions are says elastic body, elasticity of a body. What is elasticity? We say elasticity is the property of the body by virtue of the body regaining its original shape and size when the deforming force is removed. Firstly, you apply a deforming force on an object, and if the object can regain its original size and original shape, that means we say that the elasticity is perfect. Are we together, grade 12? Yes. And then deforming force is the force that changes the shape and size of the body. If I squeeze this bottle, that means I'm applying a deforming force because it will make this object to change the size and the shape. And then restoring force is the force that is equal to and opposite the deforming force. That means the restoring force is the one that will act against the deforming force. Are we together? We say when a deforming force is applied to a body, the restoring force develops inside the body to oppose the effect of the deforming force, thus restoring the size and the shape of the body. We restore the body. We have perfectly elastic bodies. It's a body which regains its original shape and size completely when the deforming force is removed. I'm applying the deforming force, and when I stop, then the body will do what? The body will go back to its shape and its shape and size. That is that only happens with the perfectly elastic bodies. And then perfectly plastic bodies, once you squeeze them, they won't go back to their original size and shape. Then we have an elastic limit, is the maximum force that can be applied. Like for instance, if I squeeze this to a point that I should not squeeze it to a point that it will be unable to regain its shape and size. If I do that, that means I'm doing what? That force, it will be the one that I apply on it, on the bottle, that it will be able to regain its shape and size. That is limiting, is what we call it. We call it elastic limit. Yes, elastic limit. And then we talk about stress. Stress is internally restoring force per unit area, and it is measured in Pascal or Newton per meter squared. Strain is the ratio of what? Of in dimension of original dimensions. We're saying the amount of the length you stretch divide by what? Divide by the original length. And Hooke's law state that within the limit of elasticity, stress is directly proportional to the strain. The stress and the strain in Hooke's law are directly proportional to each other. When you increase the stress, you increase the strain. Are we together? Then viscosity is the property of the fluid to oppose the relative motion between the two adjacent layers. That means viscosity is the one that allow the fluid to flow. Are we together? And then we say viscosity of a liquid decreases rapidly with an increase in temperature. That means when you heat the fluid, that means you are increasing what? You are decreasing the velocity, the viscosity, that you're making it to be easy to flow. Are we together? Like water and oil. And then we're dealing with what? The oil, the motor car oil. Motor car oil, they differs. It depending on what? The numbers. Like for instance, if the numbers are higher, then we'll get what? A thicker oil. Are we together, grade 12? And then we're coming to hydraulics. Hydraulics is a topic in science and engineering dealing with mechanical properties of fluids or liquids. Are we together? Then in hydraulics, we deal with what? Thrust, which is defined as a normal force exerted by a liquid at rest on a given surface in contact with. Then we're dealing with what? Pressure. We know a pressure is what? Force divided by what? By area of the object the force is applied to. And then we said at a particular point is the thrust acting on the unit area around that point. Then this is, and then when you come into pressure, we have Pascal. We have atmosphere. Pressure is measured in Pascal, but we have what? pressure that is measured in atmosphere, which is 101,335 Pascal. And a bar is what? 10 times 5, that means is 100,000 Pascal. 1 bar is equals to 100,000 Pascal. 1 atmosphere is equals to 101,325. And then 1 torr is equals to 133 Pascal. Grade 12. And then I'll skip this because this is just the symbol. And then Pascal law, it states that in a continuous liquid at equilibrium, the pressure applied at any point is transmitted into the other parts of the liquid. If I exert the force here, that means the force will be exerted in all the parts of the liquid. And then hydraulic lift, it is used to lift heavy loads. Then example of hydraulics is car brakes, dentist chair, car lift, car jack, airplanes, theme parks, cranes, and bean wagon. And then the formula, we know it. I'm not going to go through it. We saw it before. Then we come to the end of today's lesson. And then we say to you, grade 12, please keep social distancing, wear a mask, and always sanitize. Thank you very much. See you next time.